All right, here's our review. There's going to be video solutions of it, so we're going to run through all of the problems in it real quick to make sure that we understand what's going on. So, for the problems, this isn't the questions that you have to think through, but for the problems where they're giving you information and asking you to find something, it's important that you write out all of your knowns. So let's go through this first one. Looking at it, a projectile is fired vertically upward with a speed of 62 meters per second. 62 meters per second upwards is going to be my initial velocity. Because it's fired, that means it's a projectile. The only acceleration that it has is 10 meters per second squared down. Because 62 is up and 10 meters per second squared is down, the negative sign there. It's asking about the maximum height. So for the maximum height, it's a special place. I know that for something in the y direction or projected vertically upward, when we're talking about maximum height, that final velocity is 0. And we want to know what that maximum height is, so we're after the delta y. So we need to find an equation that has the initial velocity, the acceleration, the final velocity, and the delta y in it. That's this second equation, v squared equals v0 squared plus 2a delta y. I'm going to go through, subtract v0 squared on both sides, divide both sides by 2a. That tells me that delta y is equal to v final squared 0 minus v initial squared 62 squared divided by 2 times negative 10. Gives me 192 meters, which is really close to 200. So with this, it was a problem that actually used 9. Nothing on the test is going to have that particular issue on it, so don't worry too much about it. Number 2, we're going to throw a ball vertically upward. This is a thinking problem more than it's a write information down and pick an equation problem. So we want to figure out which of the following statements is true, is the most true. So we want the balls. So the velocity of the ball is the same at points A, C, and D. We know that looking at this thing, the ball slows down and then speeds up. It slows down on the way up and speeds up on the way down. We know that at C, the velocity is 0. So I know that the velocity can't be the same at all those points. So that one's out. The acceleration of the ball is 9.8 meters per second squared at every point except for C. For a projectile, the acceleration is gravity at all times, even when it's turning around at point C. That's what the acceleration is doing. It's causing the ball to turn around. The acceleration is constantly 9.8 meters per second squared. Always. That gets rid of B and C as solutions. If it says that it is 0 velocity at point C, I don't want it. Sorry, if it says that it's 0 acceleration at any point, it can't be true. The ball is the same distance above the ground at points B and D. You can look on the graph and see that they don't have the same position, so it's not the same distance above the ground. The velocity of the ball changes during its flight. That's what's happening. It's slowing down on the way up, stopping and turning around, speeding up on the way back. That velocity is changing constantly. Number 3, we're going to drop a brick, and I want to know how long it takes to reach the ground. So for this, we got to go through, identify our knowns, and identify the unknown, and pick an equation, and then solve. So, brick is dropped. That means the acceleration is 10 meters per second squared down from a height of 5 meters. That means the delta y is 5 meters down because I'm starting at the top, and then I end 5 meters below. Displaced 5 meters in the downward direction. Since it's dropped from rest, the initial velocity is 0. How long does it take the brick to reach the ground? How long is a question of time, so after time. So I want an equation that has acceleration, change in position, initial velocity. Time, that's the delta y equals v0t plus 1/2 at squared. And looking at it, since the initial velocity is 0, I can get rid of that whole first term. So delta y is equal to 1/2 at squared. If I'm solving for time, I got to get rid of the 1/2. So multiply both sides by 2. Half crosses out. I also have to get rid of the acceleration, so divide both sides by the acceleration. Crosses out over there. That leaves me with t squared is equal to t squared, I got to take the square root. T is equal to, t squared equals 2 delta y over a. So t is equal to the square root of 2 times the change in position, 2 times 5 divided by 10. Sorry about that. The math comes out to, the math should come out to answer choice E, 2.0 seconds. So I made a mistake. 2 times 5 divided by 10 should come out to 4 seconds. Sorry, should come out to the square root of 4 for 2 seconds as our time. There's a mistake on the key. All right, so number 4, got a car starting from rest. That means the initial velocity is 0. Accelerates at a rate of 2.5 meters per second squared. That tells me that my acceleration is 2.5 meters per second squared. I want to know how far the car travels in 12 seconds. So the time is 12 seconds. And I want to know how far. So I want my delta x. So I want an equation that has initial velocity, acceleration, time. I'm looking for delta x. We're going to use that third equation again. What's nice is I don't have to do any algebra. That goes away because the initial velocity is 0. So delta x is equal to 1/2 times the acceleration of 2.5 meters per second squared times time squared. Plug that in and the delta x comes out to be. Number 5, another question. Car starts from rest, so the initial velocity is 0. Accelerates at a constant rate in a straight line. In the first second, so when time is 1 second, my displacement, I've gone 2 meters. Then it's asking about the second second. How fast will the car be moving at the end of the second second? That gives me a whole brand new set of information, because what happens for this first set of information when time is 1 second is not true for this next set of information for the second second. So I need a new set of stuff. New set, the initial velocity is still 0. Now my time is 2 seconds, and what I want to know is the final velocity. In order to get that, velocity, time, and velocity, all I need is the acceleration. We need the acceleration. I'm going to go back to the other set of information and see if there's enough to get that acceleration. That's my unknown. So an equation with velocity, time, delta x, and acceleration is the delta x equals v0t plus 1/2 at squared. v0 is 0, so that crosses out. So delta x is equal to 1/2 at squared. If we solve for the acceleration, I'm going to multiply both sides by 2 to get rid of the 1/2. Then I'm going to divide both sides by time squared, get rid of the time squared. That leaves me with acceleration is equal to 2 delta x over time squared. So 2 times 2 meters divided by 1 squared is my acceleration. That acceleration is 4 meters per second squared. Means the acceleration that I need for the second. So the acceleration that we need, 4 meters per second squared for the second problem. For the second problem, we have the initial velocity and the time and the acceleration. We need the final velocity. That final velocity is v0 plus at. 0 plus 4 times 2. Final velocity is 8 meters. So, on to number 6. So number 6, we're going to drop a ball from a window, we're going to throw a ball down, and we're going to throw a ball up. So the initial instant, I have the first ball that I'm dropping, second ball that I'm throwing up with V0, third ball that I'm throwing down V0. Well, I want to know which one of these statements is true. I'm going to go through all of them. Some instant after it's thrown, the acceleration of ball C is 0. Can't be the case. The acceleration is always 10 meters per second squared down. Always. Can't be that one. All 3 balls strike the ground at the same time? No. I know that the one that's thrown down is going to hit first. All 3 balls have the same velocity at any instant. Well, if we look at this first instant, they all 3 have different velocities. That's false. All 3 balls have the same acceleration. Oh, wait. We'll just look. All 3 balls have the same acceleration at any instant? Absolutely. All 3 balls at any instant are projectiles, and so they have the acceleration of 10 meters per second squared down. They don't reach the ground with the same velocity. So the answer to that is D. For questions 7 through 9, we're going to shoot a tennis ball up in a chamber with no air. I want to know how high it goes. So to do that, it's shot vertically upward, which means we're a projectile. The acceleration is 10 meters per second squared down. Has an initial speed of 20 meters per second that's up. So the initial velocity, 20 meters per second, and that's up. The acceleration is down and the velocity is up, then I need to make that negative 10 meters per second squared. I want to know how high the ball goes. The highest point, the final velocity is 0. That's one of those special points that I know. I want to know how high the ball rises. That means I want the delta x. Our maximum height. Our max height, the velocity is 0. I want the delta y. So I need the equation with those 4 things in it. V squared equals V0 squared plus 2a delta y. Subtract over the initial velocity. Divide both sides by 2a. Delta y is the final velocity 0 squared minus the initial velocity 20 squared divided by 2 times negative 10. Delta y negative 20 meters. How long does it take the tennis ball to reach its maximum height? So for this tennis ball to reach its maximum height, it's the same set of information, and we just want the time now. We have everything except for the time. We have the 20 meters for the delta y, and so we need the time. We have everything that we could possibly need, so we can pick the easiest equation to find time. V equals V0 plus AT. Subtract over the initial velocity, divide both sides by a to 0 minus 20 divided by negative. The time is 2 seconds. Question 9, determine the velocity of the ball at time equals 3 seconds. Since we're no longer at 2 seconds like we were before, we need to start over with what we know. So we know that the ball is shot upward into the air with a speed of 20 meters per second up. We know the acceleration is 10 meters per second squared down, so it's negative. I know that the time is 3 seconds. So if I want the velocity, we'll just use the first equation because it has those 4 things in it. Velocity is equal to initial velocity plus acceleration times time. Velocity is 20 plus negative 10, 3, giving me a velocity of negative 10 meters per second, which means that it's down. We said up was the positive direction, so anything that's negative is in the downward direction. 9.4 meters per second. Okay. Move on. We're going to fire a projectile with an initial speed of 1,000 meters per second at an angle of 37 degrees above the horizontal. So right now, my known, first thing that we know is this initial speed of 1,000 meters per second at an angle. That 1,000 meters per second is not in the x and it's not in the y. It's up at an angle. That's a problem. I need to know how much is in the x, and I need to know how much is in the y. That would be how much is in the x. That would be how much is in the y. We have to use trigonometry to figure out each part of that. So my initial velocity in the x is not 1,000. 1,000 cosine 37. My initial velocity in the y is not 1,000. 1,000 sine 37. Anytime we're given a projectile at an angle, we have to break up that angle, that velocity at an angle, into what's in the x and what's in the y. So, given that, we want to know the horizontal component. So if we just look at the x stuff, one thing that we know for sure is that the acceleration in the x is 0. What that tells me is that the velocity initial in the x direction, which is going to be 1,000 times the cosine of 37. That's how I get that side of the triangle. It's the adjacent side. It means it's 800 meters per second. Since the acceleration is equal to 0, the final velocity is equal to the initial velocity because we have constant velocity in the x direction. Constant x velocity. That means at any instant, the speed of the particle in the x direction is the same as it was at the beginning, which was 800 meters per second. All right, so number 11, which one of the following statements is not true of a projectile moving near the surface of the Earth against negligible air resistance? We're looking for the false one, so we'll go through everything. Is the horizontal velocity constant? Yes, we just said it was. It's true. The acceleration in the x direction is equal to 0, so it's constant velocity in the x direction. The vertical acceleration is constant. That's also true. In the vertical direction, the acceleration is always 10 meters per second squared down. That never changes. See? The horizontal displacement is directly proportional to the time of flight. Look at this. Horizontal displacement, if the acceleration in the x direction is 0, horizontal displacement, delta x, is equal to velocity times time. So, delta x is directly proportional to time. That's true. The vertical velocity is independent of the angle of projection. False. The vertical velocity is velocity in the y direction times the sine of the angle. I need the angle to determine what the initial velocity is. Horizontal acceleration is constant. That's true because the horizontal acceleration is 0. 12, we're going to drive a ball in a high arcing shot, and I want to know what's going on at the highest point. If we look at that high arcing shot, at the highest point, the acceleration is 10 meters per second squared down because it doesn't change. The y velocity is 0, but the x velocity is the same as it was at the beginning, the initial velocity in the x direction. That's important. On a high arcing shot like that, there is some x velocity, which means there is some velocity. The velocity doesn't equal 0 at the top, and the acceleration does not equal 0 at the top. Moving on to 13, 14, 15. Second. So, this figure is the trajectory of a ball going from point A to E without air resistance. I want to know the direction of the acceleration at point B. Point B, at any point, the acceleration is 10 meters per second squared down. It's straight down. It's at all points. Which means when we get to 14, it asks, what about the direction of the acceleration at point C? It is still straight down because it's still gravity pulling it down. 15, the figure represents what's going on. Again, what's the speed at point C compared to the speed at A? we know that as we move up, we're slowing down. So because the ball slows as it moves up, speeds as it goes down, as we go from A to point C, we're slowing down. So the speed is less than it is at point A. All right, 16, we're firing a cannon from the top of a tall tower. It lands 150 meters away. What's the initial velocity of the cannonball? So, we're firing it off of a tower. It has X stuff and it has Y stuff. So, if it's a 75 meter tall tower, that's Y stuff. My delta Y, 75 meters. And since we're starting at the top of the tower and going down, my delta Y is in the downward direction. The initial velocity is going to be 0. It's a horizontal projectile. The acceleration is 10 meters per second squared down. I don't have to make anything negative here. 150 meters away is how far I move in the x direction. So the delta x is 150 meters. Acceleration in the x direction is 0, always. So delta x is going to be initial velocity times time, plus half at squared. But since the acceleration is 0, it's just initial velocity times time. If I want the initial velocity, I need the time. I'm going to get that from the y direction. So in the y direction, I need an equation that has all of those things in it. That's the third equation. Delta y is equal to v0t plus 1/2 at squared. Solving for delta y, we multiply by 2, we divide by a. So 2 delta y over a square rooted times squared time. Plug in our numbers, 2 times 75 divided by 10 equal to our time, which comes out to be 3.87 seconds. So time is 3.87 seconds. The initial velocity is delta x over time from that equation. My initial velocity is 150 meters divided by 3.87 seconds. It comes out to be 38.8 meters. My initial. 17, I have a graph of position versus time squared, and I want a graph of position versus time. So looking at this, position versus time. Looking here, I know it's a straight line, so it shows y equals mx. There's no slope. So the y value here is position. The x value is time squared. So the original graph, position versus time, is going to be x versus time squared, which is the upward facing parabola. Next, we want to find the slope of the line. So to get the slope of the line, I need 2 points on my line. I'm going to choose the origin. I'm going to choose this point up here. The origin is 0, 0. That point up there, 4, 7. So if I'm going to find that slope, the slope of that line is going to be y2 minus y1 over x2 minus x1. So my y2, 7 minus y1, 0. Then x2, 4 minus x1, 0 gives me 1.75 as my slope. Kinematic equation I have, Well, that graph shows x versus t squared. So I want the kinematic equation that has x in it and that has t squared in it. Delta x equals v0t plus 1/2 at squared. That's my kinematic equation. That's going to help me find the acceleration. So if we look at that kinematic equation, the delta x's represent my y's. v0t is my y-intercept, b. And 1/2 at squared is the mx. Well, t squared are my x values. I see that from the x values on my graph. That means the slope m is equal to 1/2 a. So the slope is equal to 1/2 a. That means the acceleration is equal to 2 times the slope. So the acceleration is equal to 2 times 1.75 meters per second squared, 3.5 meters per second squared. That's how we use that graph to find the slope. For the next one, we have a graph of velocity squared versus position. We want to draw the velocity versus position graph. So looking at this, it's another straight line, y equals mx plus b. All my y values are velocity squared. All my x values are x's. So if I'm going to draw a graph, for the original graph of velocity versus position, it's going to show v squared versus x. That's still a parabola, but it's a sideways parabola this time. V squared versus x, like that. That would be the original graph. Find the slope of the line. I'm going to choose that point, which is 2 and 9. That point, which is 14. 2, 9, 4, 14. Slope is y2, 14, minus y1, 9, divided by x2, 4, that's x1, 2, giving me a slope of 2.5. And the units for that, meters squared per second squared, my v squared values, divided by meters, or 2.5 meters per second squared. What kinematic equation describes this line? Well, if I have v squared versus x, I want the kinematic equation that has v squared and x in it. V squared is equal to v0 squared plus 2a delta x. That's the kinematic equation that goes with it. So I have to use that kinematic equation to determine what's going on with the slope. So v squared is all my y values. V initial squared is my y-intercept. 2a is my slope, and x is my x value. So that tells me that the slope here is equal to 2a, that my acceleration is the slope divided by 2. So my acceleration is going to be 2.5 meters per second divided by 2, 1.25 meters per second squared. And then according to this graph, what's the initial velocity of this cart? Well, again, because we're saying that the y-intercept is v initial squared, my y-intercept is 4. So v is equal to v squared, v0 squared, then v0 is the square root of the y-intercept, the square root of 4. The initial velocity is 2 meters per second. Last question. So for this last question, I have 2 cars on a highway, and they're going to begin like this. This is how they move. Car B moves along that sloped up line where its velocity is changing the entire time, and car A has a constant velocity at 20. So I want to graph position versus time for each of the cars. So if we look at car A shows a constant velocity, which means it's going to show an x versus time graph that has a constant slope, which means it's just a straight line. Car B shows a changing velocity. It shows me having the velocity changing from 0 to positive, which means the slope of position versus time for that is going to start off at 0. It's going to change from 0 to positive. So I start off with a 0 slope down here, and I move up to a positive slope down here. That's an upward curve for car B, showing me that it's accelerating. Determine the time at which car A and car B have the same velocity. So they have the same velocity when the graph of velocity versus time shows that they have the same value for velocity. That's going to happen when the velocity graphs cross. So A and B have the same velocity at 4 seconds. Right there. That's where they cross. That's where their velocities are the same. How far has car A traveled when the blocks have the same velocity? So to look at that, we need the area for car A. So the displacement is the area under the curve. So for car A, I need the area. That's just a square. The height is 20, the base is 4. The area is 80 meters. Then how far has car B traveled when both have the same velocity? I need the area. The area of that shape is a triangle. Base is 4, the height is 20, but since it's a triangle, it's 1/2 base 4 times height 20, or 40 meters. That means when they have the same velocity, car B has only traveled half as far, way behind car A. Determine the time at which car B passes car A. That's when they have the same area. That's going to happen in 8 seconds. All right. So review.